Up till now, when we've solved log and exponential equations, we haven't required any kind of manipulation of the equation. In these next examples, we are going to have to use some of the properties of logs before we can proceed with finding the solution. Here we have 2 log to the base 5 of x equals log to the base 5 of 9. What we should notice first is that I have a coefficient of 2 in front of the log. What I'm going to do is rewrite this as log to the base 5 of x squared equals log to the base 5 of 9. Now, you should recall that there's a property of logs that says if log base a of m equals log base a of n, then m equals n. In other words, if you have 2 log expressions equal to each other and they're of the same base, then the arguments of the expressions are equal to each other. So in this particular problem, we can say that x squared equals 9. Now to find x, I just square root both sides of the equation, and I get x equals plus or minus 3. But we should remember that the argument of a log function must be positive. Therefore, the solution -3 is extraneous. The only solution is x equals 3.
Now that we've solved this logarithmic equation algebraically, let's see how we can solve that same equation using a graphing utility. We want to solve the equation 2 times log base 5 of x equals log base 5 of 9. Since we have expressions on both sides, neither of which is 0, we opt to use the intersect method for solving this equation. We'll go to our graphing calculator, press our y equal to button to enter the left and right sides of our equation. The left side we're going to put in y1. Problem with this is that we're using log base 5 in our equation, and in our graphing calculator we can only use base 10 or base e, which is the natural log. We're going to use base 10 here and our change of base formula to enter this into our graphing calculator. So on the left side of the equation, we're going to enter 2 times log base 10 of x divided by log base 10 of 5. So 2 log base 10 of x divided by log base 10 of 5 is equal to 2 times log base 5 of x, using our change of base formula. In y2, we have to do a similar change of base formula application to change this to log base 10 of 9 divided by log base 10 of 5. We're going to go ahead and graph this using our standard viewing window. So we'll press zoom 6. And we're looking for where the 2 graphs will cross. So here we have the graph of y1, the graph of y2, which was a constant, going straight across. And we see there's an intersection point somewhere around x equal to 3. To find the intersection point, we'll go to our calc menu by pressing second and trace. We'll pick option number 5 for intersect. The first curve, and we notice previously when we've done intersection methods and when you ask for the first curve, it says we're on y1 and we would just hit enter. The problem right now is that there is no value for y present. So we need to scroll to the right a little bit until we see a value for y. Then we can hit enter to select that curve. The second curve is y2, so now we can just hit enter. And for our guess, we think it looks like x is about 3, so we'll enter 3 for our guess, hit enter. And it turns out the intersection point does occur when x is 3. The intersection point is 3, roughly 1.365. We'll drag this over. When solving these equations using intersection points, the x-coordinate of the intersection point is the solution to our equation. So in this particular case, the solution to our equation is x equal to 3.